So as a warm-up lead into the lesson, on the notes side of the page, for you guys at home, try 1 and 2, or 1A and 1B. For 1B, we're coming from the right. I think I will do the factor out thing just to save some time, since you guys seem like you're comfortable with it and walking around. Some of you had already done that. So on the first rectangle, if I'm coming from the right, I'm going to use 2.8. Some of you guys are going to start at the right and use 4.1 and work your way this way, and that is okay too. But I'm still going to go left to right on my rectangles. I'm just going to use the right-hand height. So my first right hand height will be 2.8, and then I can just list them off. And if I'm using the right-hand heights, I should get to the last one. So I should have 6 rectangles. 1, 2, 3, 4, 5, 6. So I feel good about that answer. Again, lots of safe stops. We don't want to spend time punching things in the calculator. We're good. And without knowing what this function is, we really don't know if this is an over or an under estimate, especially since it increases and then it decreases. We really don't know which one of those is more accurate. We just don't know. All right, part C and D. C says midpoint, D says trapezoid, and we haven't done those yet. So that's what today's lesson is. So notes aren't too long today. We'll just do one example of each. And then basically the assignment will be finish that worksheet. And who knows, you might be able to do it right now if you know the formula for a trapezoid. Midpoint and trapezoid rules. So first, midpoint rule. So let's back up a second. The left-hand Riemann sum, or the left rectangles, you use the height at the left side of the rectangle. The right-hand sum, you use the height at the right side of the rectangle. For a midpoint sum, we'll get the height of the rectangle at what height do you think we will use? Not the average height, that's going to be the trapezoid rule. But at the middle, at the midpoint of the subinterval. So be careful, it's not the average of the left and right. It's not necessarily the average of the left and right. If it was linear, the midpoint rule and the trapezoid rule would be the same. You don't believe me?
No, it's like if you do you have like 2 sides of it, right? And one, the other one have.
If your rectangle, or if your look like that, and you wanted the average height would be, well, the midpoint is right there, so you would use that height. That's not the average height, because this thing has some concavity to it. So midpoint height and average height don't give you the same thing. They don't necessarily give you the same thing. All right, let's use the midpoint rule to estimate the area under y equals x squared plus 2 on -1 to 3 with 4 intervals. X squared plus 2 from -1 to 3, 4 subintervals. Again, once you get good at these, you can do it without a picture, but initially it's probably helpful to see a picture. So that's a parabola, a regular parabola, but moved up to 2. So 1, 3, or negative 1, 3 are points. If I plug in 2, 2 squared is 4, plus 2 is 6. 3, 4, 5, 6. If I plug in 3, 9 plus 2 is 11. 6, 7, 8, 9, 10, 11. So there's the area we want to approximate. How wide are my rectangles? How wide is each rectangle going to be? I'm going from negative 1 to 3, and I want 4 rectangles. They'll each be 1, so that's kind of nice. So we divide it into 4 rectangles. And I want to approximate the area with midpoint rectangles. I don't really need to write that out because it told me to do that, but that's just a reminder to myself that I've been doing left and right, or overs and unders, but it doesn't want that this time. It wants midpoint. So that means at the middle of each one. So let's see, that first rectangle is 1 wide. They're all 1 wide. Again, you could factor out the 1 if you want to. You could throw the 1 away for all I care because it's just 1. I'm going to put it in there though. And I want the height at the middle. So the height at the middle, the y value at the middle is f of, so what x value is the midpoint of my first interval? What x value is right there? Negative 1/2 or negative 0.5, either way. So like visually, I'd have to think really hard if that's an overestimate or an underestimate. I feel like this is going to be a pretty good estimate. The next rectangle is 1 wide, and the height we'll use f of 1/2. Then the next rectangle is 1 wide, but we use the height at 1.5. And then the last rectangle is 1 wide, and we'll use the height at 2.5. So we're using the midpoints of the intervals rather than a left or a right. And I think you could easily see, maybe not easily see, I think you could see that the midpoint approximation for this problem would be better than the left or the right. I feel like that would be a pretty close approximation on this one. I'm going to factor the 1 out. Well, I guess it doesn't matter because it's a 1. Negative 0.5 squared plus 2. All right, I'm not evaluating any of this stuff. I'm just plugging it in because I'm not to a safe stop yet. 0.5 squared plus 2. 1.5 squared plus 2. 2.5 squared plus 2. Again, on a calculator test, they'd punch it all in and give you some multiple choices, but or a multiple choice test. But on a free response test, like, safe stop. Don't mess around with that. So right now we know 3 approximations. We draw the rectangles. You can use the left height, the right height, or the middle height. One last approximation isn't a rectangle at all. It's a trapezoid. Wait, we kind of went through that fast. Any questions on the midpoint rule? I mean, once you know the left rule and the right rule, it's the same thing. You're just adding rectangles. All right, trapezoids. I guess part of the confusion is usually in geometry, like, all your trapezoids look like that. That's probably how 95% of the trapezoids in geometry are drawn. But in here, we end up wanting to use trapezoids that look like that. That way they can fit under the curve and approximate that area better for us. Now, we did this briefly on Tuesday with area of trapezoids, but we can quickly review here. Area of a trapezoid is the width times the average height. The width times the average height. So the 3 rectangle rules are add up the rectangles. The trapezoid rule is add up the trapezoids. You know what? Let's do the same shape here. Let's estimate the area under y equals x squared plus 2 on -1 to 3 with n equals 4. So I'm going to draw the picture again. Again, maybe you get to a point where you get away without drawing a picture, but I also think drawing a picture forces you to slow down a little bit, forces your brain to kind of process the problem rather than trying to jump in and do formulas. It kind of backs you up to slow down. Let me think about what a parabola looks like. Maybe I just plug in some points. Picture drawn. I want 4, so the width is 4 again. Or excuse me, the width of each section is 1. And we'll have 4 trapezoids drawn. Let's see. So here's my first trapezoid. This is going to take a little more space to write because you got to write the average height each time. So either write smaller or make sure you got enough room. So trapezoid rule, that's an approximately equal sign there. So my first trapezoid, trapezoid A, if I'm going to label them here. So its width is 1 and its average height be the height at -1 plus the height at 0 all over 2. We'll plug in those later, but f of -1, f of 0. The height at -1, the height at 0. That's my first trapezoid. I'm using the height here and here.
Okay, yeah, I got it.
So f of -1, f of 0. I'll plug those in a minute.
Yeah.
Trapezoid B, the width is 1. The two heights are f of 0 and f of 1. Why don't you see if you can finish setting up the problem with trapezoid C and trapezoid D. Again, the labeling might be a little overkill, but helps some people visualize what's going on. Okay, good with that? Now, the trapezoid rule is especially a place where the books go crazy with factoring stuff out, because there's always a 2 in the bottom, so they'll factor that out. Whatever the width is, they could factor that out. And then they'll reduce the formula because there's all the middle points get used twice. Like all the inside heights, there's 2 f of 0s and 2 f of 1s and 2 f of 2s. But there's only 1 of the end heights. And so when you look at formulas, I don't want to say it's misleading, but they have some stuff out front, and then they'll have 1 of the first height plus 2 of all the middle heights plus 1 of the last height. I don't really even like doing that, because then you lose sight of the fact that you're adding trapezoids. Just stay here and fill in what we know. You can factor out the 2 if you wanted to, because that would clean up a little bit. So I am going to factor out the 1/2. And that leaves f of -1 plus, here's where we get a little bit confusing, there's 2 f of 0s. And there's 2 f of 1s. And there's 2 f of 2s. And there's 1 f of 3. Now, again, you look in books, they jump to this spot, and you're like, where did that come from? Don't worry about memorizing that. Worry about starting here, where all you're doing is adding trapezoids together. So f of -1. I guess I could actually plug these in. Otherwise I'm going to be writing a whole lot of stuff. -1 squared plus 2 would be 3. Plus 2 times f of 0 is 2. Plus 2 times f of 1 is 3. Plus 2 times, running out of colors, f of 2, 2 squared, 4 plus 2 is 6, plus f of 3, definitely out of colors now, f of 3, 9 plus 2 is 11. And that's a safe stop. But if you're curious, it equals 18. All right, your assignment is that Riemann sums worksheet. Finish it. Is the short story. Let's try to do C before we go, because this looks a little bit weird. Use a midpoint sum with 3 subintervals. So with 3 subintervals, that means I need to go 0 to 40, 40 to 80, 80 to 120. So how wide are my intervals? What was that? 40. So my intervals are all 40. Which means I could factor that out if I wanted to, but which height am I going to use on this first? So for this first rectangle, which height do I use? I got three options: 2.3, 2.8, or 4.3. Why 2.8? Because it's in the middle and I want a midpoint. For the middle, for the second rectangle, between 40 and 80, what height do I use? 4.3, 5.7, or 5.2? Why 5.7? It's in the middle. And then for the last one, 5.2, 5.2, or 4.1? The middle, 5.2. So be careful, read carefully. Also on that last one it says 3 subintervals for trapezoids. So you have enough info to do 6 trapezoids, but it doesn't want you to do 6 trapezoids. It wants you to do 3 trapezoids. So try that. We'll go over those tomorrow.